Dear friends, we are concerned with the robot kinematics. We know that the robot manipulator is made up of various links and joints. In order to find out the kinematics of the manipulator, it is very important to understand the relationship between the one link with another link. While finding out the kinematic analysis, we generally compare the position of a one link with another link and correspondingly with the endpoint. So the position and the orientation of the endpoint in the case of a manipulator is very important while calculating the kinematics. So in order to find out the kinematic equation of any of the manipulator, it is important to understand the basic geometrical fundamentals or geometry fundamentals. So here let's consider, so this presentation is related to the finding out the position and the orientation of any point P in the coordinate frame. So we know that the links and joints are there in the three-dimensional space, and in three-dimensional space a coordinate frame is a set of a three orthogonal right-handed axes. Axes x, y, z are called the principal axes, which we are generally studied during our basic fundamental course of the mathematics. So let's consider any point P in the three-dimensional space whose position we want to find out. So let's consider the three different, the orthogonal right-handed axes, axis x, axis y, and axis z, and this is the position of point P. Now the position of point P is arbitrary, which can be represented as the vector OP from the origin of the orthogonal right-handed axis. So here the origin O is related to the position P, where the projection of a point P on plane xy is represented like this one, like px, py, and pz are the projection of a point P on coordinate frame x, y, and z. A point P in a three-dimensional space can also be represented as a L and vector O and a P. In a vector notation, the vector P is equal to the px times x cap plus py times y cap plus pz times z cap, where px, py, pz are the components of vector OP along the coordinate axis. So here in the field of the robotics, because we need to define the different frames on the different joints, so in order to represent one link with another link, we need to define individual link with different frames. So in order to specify the individual frame, we need to assign a particular frame name. The frame name can be given, it can be labeled as a XYZ frame if the coordinates are supposed to be XYZ. It can be named as frame 1 because it is the frame 1. If there are the 1 and 2 different links are there, so it may be the frame 2, frame 3, frame 4, and so on. If the frame is connected with the origin, so it can also be represented as a frame 0 in certain case if the manipulator kinematics you are finding out. Now the position of point P with respect to frame 1 can be written like this one. Position of point P with respect to frame 1 can be written with this equation, in which where P with respect to 1 refers to the point P or vector OP with respect to frame 1 and its component in the frame as P1x, P1y, and P1z. In vector metric notation, the equation can be written in the form of a vector components, like the position of a point P with respect to frame 1 can be written like this one, and it can also be written like this one, where this capital T represents the transpose of a matrix. We can also find out the value of a L by finding out by adding the direction cosines of vector OP, which can be expressed as a cosine of a alpha, cosine of a beta, and cosine of a gamma. The overall equation L can be written as, where the magnitude of vector OP can be represented by this equation. So in this way, the position of a point P in the three-dimensional space can be found out. This is the basic fundamental equation to find out the point P in the three-dimensional space. Is a very fundamental part of a mathematics which we used to find out the kinematic analysis. In my next lecture, we will find out the relationship between one frame with another frame. While finding out the kinematic analysis, some of the joints are revolute joints, some of the joints are prismatic joint. In the case of a prismatic joint, there may be a linear transformation. That means if the one frame is linearly transferring from one frame to another frame, there may be a chances in some mechanical constraints are there in which the one of the link part is translating as well as rotating. In that case, if we are assigning one frame at the end of the manipulator link and one frame on the base part of the manipulator link, in that case, if it is rotating and translating, then translation and rotations may be there. So in that case, the mathematical relationship is there which need to find out. So in my next lecture, we will study all the three cases, while whether it is rotating, pure rotation, pure translation, or a combination of a rotation and translation. Thank you.